Yes, good morning, everyone. In the last class, we were discussing about network address translation, that is NAT. So in this, what happens that private IP is being mapped with the public IP to reach the internet, right? In this, we have different methods for doing this NAT. One is called as a static NAT, right? So what happens in the static NAT? It is like a one-to-one mapping where one private IP address is going to be mapped with one public IP addresses to reach the internet. So we have discussed that this static NAT we prefer from which side? Like a server side, correct? Then here what happens that only one private IP is going to be mapped with a single public IP. But what if I'm having multiple different ranges of the private IP addresses? So there we prefer the dynamic NAT. So here what happens that we will be having multiple private IP, right? So again, multiple private IP address is going to be mapped with multiple public IP address, or we can say that particular is going to be pool of public IP address. But here again, the same scenario is that one private will be mapped with one single public to reach the internet. So we prefer this particular type of dynamic NAT only when we have limited number of IP addresses, private IP. But the most efficient way to have this NAT is PAT. That is called as what? Port address translations. So in this, what happens that we will be having multiple private IP address, but that multiple private IP address is going to be mapped with single public IP address. And just what will change? Unique port number will be assigned, right, to each traffic. Based on that, it can be identified that this traffic belongs to this particular private IP, so that the return traffic can be delivered back to that particular private IP addresses. So we have discussed a static NAT and dynamic NAT configuration. Today we'll complete PAT, port address translations. For that, we'll take one router. One switch, then PCs, then again you can take one more router. Then what is required? Routing will be required because we have taken here two router and one server will take. So on this interface, IP will take is 10.1.1.1/24. Let's say 10.1.10. Then this is going to be 10.1.1/24, 10.1.1/2/24, and this is 10.1.1/3/24. This side will take one public IP, let's say 8.8.8.8/8. Okay. Here we'll take 8.8.8.8.9/8. Correct. This side again will have certain private IP 192.168.1.10/24. Then 192.168.1.1/24. Then come to this router. Enable config space host name. Let's say NAT router. Then interface we have is G0/0. The address is 10.1.1.1, 255.255.255.0, and give here no shut and give exit. Then interface G0/1. IP address is 8.8.8.255.0.0.0 because /8. Then give no shut and give exit. Then come to this router. Give no, enable config space T. Host name, let's say, is going to be ISP. Now here we have interface G0/0 first. So interface G0/0. IP address is 8.8.8.9 and 255.0.0.0 and give here no shut, give exit. What interface we have? This side G0/1. So interface G0/1. IP address is 192.168.1.10.255.255.255.0. Give no shut, give exit. Now come to this individual PCs and servers. Desktop IP configurations. 10.1.1.1.
Router
1 minute to show IP interface.
10.1.1.
So interface G0/0. IP address 10.1.1.10, right? 255.255.255.0 and give here no shut. Give exit. Again verify to show IP interface preview. Yes, changed. Now come to PC. 10.1.1.1. 255.255.0. What is the default gateway? 10.1.1.10. This one is the default gateway, no? Come to second PC. 10.1.1.2. 255.255.0 and 10.1.1.10. Ten dot 1.1.10. Now come to the server. Desktop IP configuration. 192.168.1.1. Then 192.168.1.10. Correct? Now next, see here we have one public IP. See, without even doing any NAT also it will ping. It is Cisco packet tracer, right? But in a real scenario, we have to do the NATing because we have here private IP and here we have the public IP address. So first we will do the routing here. Preliminary routing command. Whatever you want, like dynamic or static, anything. IP route. We have to reach which network? 192.168.1.0 network. So 192.168.1.0 255.255.255.0. What is the next hop? 8.8.8.9. Correct? Done. Now we have to give here NAT command. So first for that, we need to create a access list. So access list, then one permit. What we have to permit? All the network coming under this, or means all the IP coming under this network. So 10.1.1.0. This is what network address. Then it is /24. So what we have to write here? Wildcard mask. So what is that? 0.0.0.255. So access list one, permit, a network, and then why we have given here wildcard mask. After that, what we have to give here? IP NAT, pool, then pool name, pool P1. Then we have to give here source IP and destination IP. Dynamic NAT, we have, remember, no? Same command we have to give. So we have to give starting IP address. What is the starting IP address? 8.8.8.8 public IP. Then last IP address will be same 8.8.8.8. See, remember, in the dynamic NAT, we have given the starting IP address, that is starting public IP address, but the last one was changed. Means we used to give a range. Let's say from 8.8.8, I have given 8.8.8.10. So it means 9, 8, 9, and 10 I have given, right? But as I have given here same only, it means I want only single public IP. That's why I have not changed the value, right? Next, you have to write here net marks. What is the net marks here? /8. So value is going to be 255.0.0.0, right? Again, if you give a question mark, nothing is required. So IP NAT pool P1, then starting IP address and the end IP address is going to be same in the case of NAT overload, or we can call it as a PAT. After that, IP NAT inside source list 1 and pool P1. So if you are giving till this the command, that it is going to be act as a dynamic NAT only. But here we have to make it overload. So at last we have to give a remote command, that is overload. In this only. Here only we'll add overload. So IP NAT inside source list 1, pool P1, and overload we have given. Then what is required? Implementation. So interface G0/0 IP NAT inside. Then interface G0/1 IP NAT outside. Then now you verify. Ping to 8.8.8. Sorry. Ping to 192.168.1.1. You exit and check show IP NAT translations. See? So here this 10.1.1.2 is mapped with same, when even 1.3 is being mapped with 8.8.8 only, and even 10.1.1 is also mapped with the 8.8.8. Clear, no? So everywhere what you are finding here, that my single public IP address is being used to map with what? My multiple different private IP addresses. And what is the difference? Virtual port numbers, right? Each traffic is getting what? A port numbers. Like here you have got 1024 and same, it is hitting to the internet also 1024. Correct? No? So it means here multiple private IP address, but we have only single public IP addresses. And this is called as a NAT overload, or we can call it as a bad port address translations. Clear it is? Note down the commands now. So PAT is equal to what? Port address translations. In this multiple private IP address will be mapped with single public IP address to reach the internet using different port numbers. For that, first we have to create an access list. So we'll create access list, then ACL number, permit, then the network address that we have to permit, then wildcard mask, then IP NAT, pool, pool name, then source or not source, we can write starting, we can write starting public IP address and same end public IP address. It means we don't have to change that. Then we'll write here net mask, and then we have to write here subnet mask. Then IP NAT inside source list number, pool and pool name. And at last we used to write here what? Overload. And then interface and interface number, IP NAT inside, same interface and interface number. And this time IP NAT outside. If you want to write the example, you can write it. Example is going to be X, like we have given here. Access list. ACL number we have given 1. Permit 10.1.1.0. Then 0.0.0.255. IP NAT. Pool P1. Then 8.8.8.8. And again 8.8.8.8. And net mask is 255.0.0.0. Then IP NAT inside source list 1 and pool P1. And at last, what we have to write? Overload. And then you have to implement. Like here, what we have used? Interface G0/0. So interface G0/0. IP NAT inside an interface G0/1 IP NAT. Clear till here? Done. So this week completes NAT. We'll start with the new topic now. Okay, listen now. See what happens. Let's say, for example, we have so many end devices. They have to reach the internet. For that, what is required? Router is required. Forget about NAT as of now. Router is required. And end devices should know about what? Default gateway. Because everything we have to configure on the routers. But what about the end devices? What they need? They need the default gateway. Now, if you have a single router, what happens if you have a single router? Then all these end devices will be having a default gateway of that single router interface, right? Now, what if that particular interface is not working? What if that router is not working? Then what will happen? The devices in my network will not be able to reach the internet or will not be able to communicate the devices outside my network, right? Or you imagine one more scenario. Let's say, for example, what happened that whenever you have any, like you have purchased certain things and you have to complain about that. So what you prefer? You have to dial a customer care number. So for example, you are dialing a number 198. Okay. So whenever you dial, is it same person is receiving that call?
No.
Different, no? It means what is happening there? They're having a backup. It means they are going to have backup. But what you do, you always dial the same number, no? Don't dial these different numbers. So same as what will happen, you can consider that we are going to have multiple end devices. So that end devices will be reaching the internet using certain default gateway. But instead of having only single router, I may have one more router. It means I will take two routers, right? So if two routers, two different interfaces, and that will be acting as what? Default gateway. But on the end devices, you are not going to give the IP address of one of the router interface. Means you will be giving here a VIP that is called as a virtual IP address. And that particular virtual IP addresses will be acting as a default gateway. And based on that only, they will be able to reach the internet. And here what we are providing? Backup. How? Because we have not taken one router, we have taken more than one routers. And this concept is called as a FHRP, that is called as a first hop redundancy protocol. Okay. Now to understand with the scenario. Here what happened that we have taken one router. One router we have, and we have taken one switch and multiple PCs we have. This is router 1. Then this is switch. This is PC1. PC2. And this is PC3. And this side we have internet as well. Okay. Now let's consider that interface here we have is G0/0 on the router interface. Okay. Yeah. On the interface G0/0, we have configured one IP as well. Let's say IP is going to be 192.168.1.1/24. Okay. And this is going to be 1.2. Then this is going to be 1.3. And this is going to be 1.4. Okay. Now, as you know that if this PC has to reach the internet, for that, this all PCs require what? Default gateway. Yeah. And here you will write the default gateway as what? 192.168.1.1 on all these PCs. Now let's consider that this interface is not working. Then what will happen? My devices will not be able to reach the internet. Or if there is any problem with the routers or the router interface. For that, what we want? We want a backup. For that, we have taken one more router here. Okay. Again, we have connected this. Let's consider this is also one interface. G0/1, for example. IP address here we have configured is 192.168.1.5. Okay. Here we have 1.4 till PC, and here we have taken as a 1.5. Correct? No. This is router 2. Now here we will be having a router means IP will be of same network, no? Because this has to this IP is going to provide what default gateway for all these PCs. So it should be of same network. Correct? Now here the question comes that on the PC, which default gateway if you write? See, if I am writing on the PC1 that default gateway is 1.1, then it will always send the traffic via 1.1. If this 1.1 is not working, it is not going to divert the traffic from router 1 to router 2 because already I have given that you have to go from 1 only. Same as if, for example, on the PC2, you have informed that, okay, for you, the default gateway is going to be G0/1. Okay. Again, this if G0 interface G0/1 is not working, then this PC2 is not going to divert its traffic automatically from router to the router 1. It will not do now because what we have given the information regarding the physical interface, right? So it may be possible that if router 1 is having interface 0/0 means default gateway information as 1.1 and PC2 is having a default gateway information of router 2, and if one of the router is not working, in that scenario also one of the PC will be able to reach the internet. That is possible. But I want that all my devices would reach the internet. There should not be any partiality. So for that, what we are going to use here, FHRP concept. So it says that instead of giving the IP configured on the physical interfaces of the router as a default gateway for the end devices, here we have to give IP as a VIP. That is what? Virtual IP address. Okay. So let's consider IP will be having 192.168.1.50. Okay. This is the virtual IP address I have given 192.168.1.50. Now, based on this, what will happen that we will be giving PC1, PC2, and PC3 as a default gateway 192.168.1.50. Right? So default gateway is what? Is virtual IP. but they router 1 and router 2 is having their own IP addresses on the interfaces. So how they are going to identify this? Based on the configuration of the FHRP. So they will be keep sending the hello packet messages to verify which router is working and which router is not working. Now let's consider there can be one scenario where both the my routers are working. Means a router 1 is also working, a router 2 is also working. Then what will happen? Are you going to send the traffic via R1 and R2? Like what I am telling you. Here we have taken two routers to keep one as active and one as a backup. But if both the router is working, then what will happen? In this scenario, only one router will be considering as active and one has to wait. It will be in the standby. Okay. Now, how it is going to identify? See, now router 1 is also active, router 2 is also active. Then by which router the traffic will be passing? That will be decided based on the priority number. The router with the highest priority will be the active router. And the router with the least priority is going to be what? Standby router. So let's consider that by default in the HSRP, see what happens that as of now we are discussing this concept. So concept is called as a FHRP. That is what? First hop redundancy protocol. This is the concept. But under this, we are going to use certain protocols. So this is the concepts. Under this, the protocol that we will be using is called as a HSRP. Hot standby router. Okay. Under this FHRP, we have certain more protocols. One is HSRP. One is called as a VRRP. Okay. Virtual router redundancy protocol. And one more we have that is called as a GLBP. That is gateway load balancing protocol. Here we have to understand only one protocol that is called as a HSRP. That is called as a hot standby router protocol. So the concept that we are discussing is approximately same for the HSRP also and the VRRP also. Okay. In both the cases, here we will be having one router as an active. Whereas in the case of GLBP, the name only suggests that it is going to perform what? Load balancing. It means here it will choose both the routers. It will send some of the traffic via router 1, some traffic via router 2. That's why it is called as a load balancing. But in this case, in the HSRP case, we don't have to do load balancing. We will prefer only one router as an active at one time. So now in HSRP, what happens? The router will be having by default priority number, and that is going to be 100. If any router is having higher than that, that will be considered as a active router, and other will be called as a what? Standby. Now, if the router has same priority number, then the router with the highest IP address is going to be the active. And then in this case, if router 2 has 1.5 and router 1 has 1.1, so 1.5 is going to be what? Active router. Right? So what is the case? Here one router will be as active and one is going to be the standby. Now, here I have taken two routers. One is active, one is standby. If let's say I have taken more than two routers, then for example, here I have taken 1, 2, and 3. Then other router will be called as what? Candidate routers. Candidate, right? So if more than two is there, so one is active, one is standby, and one is candidate. Then if candidate is not working, like if active is present, then a standby will be there, then candidate will be there. Okay. If active is not working, then who will work? Standby. Standby is not working, then candidate, like that. Clear, no? So see, what is it? That the term FHRP refers to the category, right? So this is the category, or we can call it as a, like this is a concept of the protocols that can be used so that host takes advantage of the redundant routers in a subnet. Now, all hosts acts like they always have with one default router that never has to change, right? Means the router, the end devices will be having what? The default gateway information, and that we call as what? Default router. Now, the default routers in the case of FHRP shares a virtual IP address in the subnet defined by the FHRP, and host uses the FHRP virtual IP address as their default router's address. Instead of providing the IP of that interfaces, what we're writing here? Virtual IP. The routers exchange FHRP protocol messages so that both agree as to which router does what work at one point in time. It means they will be sending what? Hello messages to determine who is working and who is not working. Correct? No? Now, when a router fails or has some other problem, the routers uses the FHRP to choose which routers is going to take over the responsibilities over the failed routers. It means, according to this scenario, let's consider that all the traffic is being passing through the router one, for example. Okay, so this is going to be, let's say, active, and this is going to be what? Standby. So all the traffic will be passing through this one. Now, if this particular router is not working, this interface is not working, then what will happen? Automatically, this will become active. Okay, and this is not going to be standby. This will be called as an unknown. Why? Because it is not working, no? Now, one more thing. Now, later on, what happened? Let's consider that this was my original active router, no? And this was what? Standby. It was not working. So what happened? That this second router became active. After a certain time, what happened? Router 2 automatically came active, or means you can say it started working. It started working again. Then what do you think? All my traffic will pass through this? It should shift. Huh? Let's say we have a captain of the team and vice captain. Today, what happened? That captain was not feeling well, so he was absent. So what happened? Vice captain was taking all the charges, right? Now, when he came back, so all the charges will be shifted toward this or not?
Yes, yes, yes. Yeah.
Huh?
Yes.
Because he's the captain of the team. No, now he's present. So vice captain should share all the charge, all the responsibility to the whom? To the captain. But in this, it will not happen. He will tell now, no, I will be the captain. Always he will say, I will be active.
Mhm. Do we need to configure again the PC?
Huh? No, VIP is there, no. Virtual IP is there. PC is not worried about anything. They are thinking that, okay, I have this VIP. Router will decide through which traffic will pass.
VIP will shift to our.
Not VIP. Both the routers, on both the routers, we have to configure. So when we will configure on the router one, we will inform that, see, there is a virtual IP, this one. On the router two also will be configured that there is a virtual IP, this one. So they will come to know and they will be sending the hello packet messages to verify. Okay, if one of the router is not working, it will not receive. If it is not received, it means that is dead, unknown. So it has to come active and it will become the active. But if again my router 1 started working, so if it starts working also, then all the traffic will not shift towards router 1. Always it will keep on passing through the router 2 only.
Will it be standby or candidate?
Who?
Unknown.
This will be unknown, no.
Even
Because no, if it starts working, then it will be standby automatically.
not candidate.
Like two router we have, no. And this is going to be what? Active.
If it was 3 router, it will be candidate.
Huh. Okay. And the term that we are discussing now, that it is not going to change my router 1 as active automatically. This is called as a preemption. What is called? Preemption. And in HSRP, it is disabled. You have to enable this. How to enable this? We'll discuss in CCNP switching part. Right? But in this, it is disabled. This is the concept. Got? Tell me fast. See, if we want to change, we can change the priority number. No, even if you will change the priority number, in that case, router 2 will be the active router. Based on the priority number, it can change, but by default, it is not going to change automatically. We have to do certain changes. Right? Got the idea? So let us configure. Maybe it is going to be more clear then. What about online guys? Is it clear till here? See,
Yes, sir.
this HSRP is Cisco proprietary. It means this is Cisco feature. Here what we have, standby and, and active. VRRP is open standard. Okay. And GLBP is also Cisco. In this, we have like a master. Same concept is here for the VRRP, just terms will be different. And in this VRRP, preemption is enabled by default. Want to see what is preemption? Hmm. HSRP does not support preemption by default. So when a router with lower priority becomes active, it does not automatically transfer its active status to a superior router. The same thing we have discussed. The router with that was active. Router 1 was my active router. Then what happened? And router 2 was my standby router. Then there was a certain problem with the router 1. So that's why router 2 became active. And this was unknown. Later on, what happened? That this second router started working again. In that case, according to the highest priority number, you can consider that this should be my active. And again, this should be my standby, but this will not happen. This will be in the standby only. Why? Because of this concept, preemption. So preemption is by default disabled in the case of HSRP, but in the VRRP, it is enabled by default. We can enable this on in the HSRP also, but for that we have to give a command. Is it clear? Now see HSRP. So HSRP operates with an active and standby model, also more generally called as active or passive. So HSRP allows two or more routers to cooperate, all being willing to act as a default router. right? However, at one time, only one router actively supports the end user's traffic. Then the packets sent by host to the default routers flow to that one active routers, and then the other routers with an HSRP standby sit there patiently waiting to take over when the active routers have a problem. Correct? Next, the HSRP active routers implements a virtual IP address matching with a virtual MAC address, because you know that it's required. The PC require what? MAC address also. So this virtual IP address exists as a part of what? HSRP configurations, which is an additional configuration items compared to the usual IP addresses interface commands. And this virtual IP address is in the same subnet. Means network should be same as the interface IP addresses, but it is a different IP address. IP is different, but network is same. And the routers then automatically creates the virtual MAC address. See, here we have run router 1, router 2. So this is going to be active. This is going to be standby. So all the traffic is passing through whom? To the active, right? In the second case, here it says that this is my not working. This is not working. That's why this is unknown. And this is going to be active. And all the traffic is passing through this one, right? Let's configure now. See, here we'll configure an IP 192.168.1.10/24. This side will configure one IP as 192.168.1.5/24. Then here we'll configure one IP 192.168.1.1/24. This side 192.168.1.2/24. And this side we will be have one virtual IP that is going to be 192.168.1.100. Okay. See, now we'll come to this router. CLI give no enable config space t. Host name is going to be R1. Interface C. Directly we configure interface IP. Interface is what? G0/0. And IP address is what? 192.168.1.10.255.255.255.0. Give no shut and give exit. Same we have to configure on the router, second router as well. CLI give no enable config space t. What is the host name? Router 2. Interface G0/0. IP address is 192.168.1.10. 100. 5, no? And 255.255.255.0. Give here no shut. Give here. Done. Now we have to configure the IP on the PCs. So come to which PC? Desktop IP configurations. 192.168.1.1. Now, here the default gateway, we don't have to give 1.2 or 1.5. What will give? 1.100. 192.168.1.100. Same here also you have to give. One 192.168.1.2 and default big gateway is 192.168.1.100. Correct? Now come to this router. Here we have to configure the HSRP. For that, we will configure interface number. First, we have to give interface number G0/0. We are telling him that, see, on the interface G0/0, you have to take one standby, like a stand IP will be there, virtual IP will be there. That is what is a 192.168.1.100. So for that, you will configure standby. Both the side we have to configure the same thing, standby. Question mark. See, what is it in here? Group number. So write a group number. Let's say 1 I am writing. Then what is it in? Enable HSRP and set the virtual IP address. Okay. So standby 1, then IP, then write the virtual IP address. What is that? 192.168.1.100. Just one line command we have. Standby, group number, IP, and virtual IP. On this, we have to configure where? On the physical interface. On the router 1, we have configured on the 0/0 interface. Same thing we have to do on the second router as well. Which interface? Here also we have our interface number. So G0/0, standby, group number, IP, which IP? Virtual IP 192.168.1.100. Done. Now you have to verify. Now see what it says. The first router is what? Active. How will you check? Give show standby. If you are giving command show standby, it says a state is active. Virtual IP address is active. Virtual MAC address is right. Then what is a hello timer? 3 seconds. What is a hold on timer? 10 seconds. It means it will every 3 seconds it will send hello packet. If till 10 seconds it is unable to receive, it will tell that my router is not working, my neighboring router. Then only it has to become what? A standby or active according to the scenario. And see, preemption is disabled. An active router is local. This is the active router, the first router that we are seeing. And standby router is what? Second one, 192.168.1.5. And what is the priority value? 100 is the default priority number. Clear, no? Now you come to second router.
Vishal, the preemption can be here enabled by manually?
Yes, we can manually enable. Yes, we can. Okay. We can enable it.
Thanks.
On the router 2, what it says? It is state is standby, virtual IP address, this one. Active router is MAC address. Hello timer 3 seconds. Hello timer is 10 seconds. And who is the active routers? 1.10. First one. Correct, no? Then what you can do, you can take one more router here, this side, connect this, then you can do the routing. Then you can take it, check it from the PC. When you will give the command on the PC, trace route. See what you will do. Not everything I will be doing. No, you will take a router here, connect. Here also connect. Fine. Do routing here. Correct. Then when you will check, let's say here we have configured one IP 1.1.1.1/24, for example. You will check it from this PC. How will you check? Tracer 1.1.1.1. It will show you the path, how it is going, how it is traveling there. So it will show you that I am going via 1.10 or 1.5, which route it is taking. So trace route command you can verify on these PCs. Correct? For that, what is required? You have to take one more router, do the routing between them. Then only it is going to exchange the route information, because here we will be having more than two routers. That's one router. That's why. Same thing. You have to do it from this side also. Okay. Don't go with that static routing. Use EIGRP or noise. Better to go with the EIGRP. Simple. Okay. Next. Now come to this router. Come to config space T. Now give a command interface G0/0 and make it shut. This is my active router. Now not working. Let's check what will happen. Second router is what? Active now. Show standby. What it says? State is active. Active router is standby router. Unknown. It is not getting any reply from that. That's what it is saying you as an unknown. Now, at present, my router 2 is what? Active. Router 1 is what? Unknown. Now, make the interface up. Now check. Show standby. What it says. Again check. Show standby. Active router is what? 192.168, 1.5. No. Active router is 1.10. First one. Okay, so here it is. What is happening? If this router is available, it is coming up. Like if it is again coming, if it is again working, so it's shifted. But in the real scenario, it will not shift. Even you can verify in the EVNG, it will not happen. Okay. The reason preemption is disabled here. Correct? No? Now, how to check this priority number? Come to config space T, interface G0/0, standby 1. Yeah, priority. interface, interface number, then standby, group number, priority, and you can give a question mark. And this is the range of the priority number that we can use here. 02255. What is the default one? 100. So if you will change here the priority number, let's say for the router one, I am changing it to the router 2 only, second router. So come to config space T and give interface G0/0, standby 1, and priority is going to be 200. It means this is the highest priority number now, right? Fix it. See, it has been changed now. Priority is what? 200. 200. See, it is having the priority is 100 only still. So in that scenario also, who is the active router? First only. It has not changed, even if it has less priority number. Correct? No. The reason? Preemption. So standby. So it says still by active router is the first one only. And this is what? Standby router. So write down the commands to change. In HSRP, virtual IP is configured as default gateway on the end device. VIP is configured as a default gateway on the end devices. What is VIP? Virtual IP address. So routers will exchange hello messages, and based on this, one router will be active and other will be standby. All the traffic will pass through active router. If active router is not working or the interface connected with active router is not working, then all the traffic will pass. Then then standby router will become active router. The command that we have to configure is standby. Then we write, okay, first interface number, then a standby, then group number, IP, and here what we write, virtual IP. to change by default priority number on the router in HSRP is 100. To change the priority number, the following command will be used. Interface number, then standby, group number, priority, and here we have to give the which layer protocol it is. Layer 7 protocol it is.
Yes, sir.
But when will you search, you may get the solution as a layer 3. But it has port numbers, it uses UDP, that's why. Okay. Is it clear? Clear? So standby. To check, you can write this. Clear? This will complete FHRP as well. See, there is one concept called as a triple A. Triple A. What is triple A? This is authentication, authorization, and accounting. So it is like a security, network security and management. So triple is a fundamental concept in network security and management, ensuring that network remains secure and function smoothly. See, for example, let's say you are going to access any of the devices. For example, firewall we have, any firewall we have, or any cloud platform we have. So when you are going to use cloud services or firewall devices, then if you are going to access it, so first time it is going to ask you what? Authentication. Any devices also if you have, it will ask you what? Authentication. What is authentication? This is the process of verifying the identity of a user or a device. How it is going to identify this? It ensures that only authorized individuals or devices can access the network. So common methods that is include is password or biometric scans. Means if you want to access any particular devices for that, for the authentication purpose, it will ask you username. And then what it will ask you? The password. Apart from that, we can have other thing as well that is called as a biometric scans. Okay. So once you have given the correct username and once you have given the correct password, then what will happen? You will able to log in there. You will be able to access the devices. So first step is completed if you are giving a correct username and correct password. So based on that authentication is completed. So next you will come to which state? Authorization. So after authentication, the authorization determines that what an authenticated users or devices is allowed to do. Means if you have once authenticated, so what all the functions is allowed for you. And it sets permissions and access labels to ensures users only access data resources they're entitled to. It means that based on their based on your authorizations, you will be allowed to do any specific work there or specific changes there. Now, for example, let's say you have logged in there with a username and password. Then based on your authorization, you can be classified as a guest, right? You can be classified as an admin, right? You can be classified as a super user, right? Now, if you are going to log in there as a guest, what will happen? You will not be able to do any changes over there, right? So what you will do, just you will observe the things, correct? Just you will see the things. You cannot do certain changes, fine? Now, if you are going to log in there as an admin, you will perform the changes, fine? You can edit the files, you can delete the files, everything you can do. But maybe again, you cannot do one more thing that is you can't add any new admin, right? Can't add a new admin if you are as an existing admin, right? But when you are logging there as a super user, then you will be having a more control, right? You can create, you can delete, you can modify, you can allow, you can deny, you can even create a new admin there. So multiple things will be allowed for you when you are going to log in there as a different authorizations. So when you will go for for example, we have a Palo Alto firewall. There we have all these things: guest, admin, super users, all other users. All the things will be there. Based on that only, what will happen? Your authorization is being decided. What is being allowed? Okay, that's why it sets what permission and access labels to ensure only who is going to access this data and what all the resources is being allowed for him. Okay. So whenever you will log in there, no, so what will happen? Some other things will be visible for you, and some other things will be visible again, but you cannot click on that when you are going to log in there as a guest. For example, if you're logging there as a super user, then multiple features will be displayed for you. Even you can do certain changes on every of the specific you can say uh, whatever we have. Like say you have to create a NAT policy. Okay, you have to create a more security policies. So maybe everything will be allowed when you're logging there as a super user, but maybe the security policy will be not visible, or it can be visible, but you cannot click over this if you're logging as a guest. So these changes will be there, right? Last one is what? Accounting. What happens? This involves tracking and recording the user's activities. So once you have logged in there, now first password is being verified for you. Next is your authorization is being verified, that let's say you're a guest. Next, whatever the activities you will perform there, everything will be recorded. And this involves accounting. So this involves tracking and recording the user's activities and network resources uses. And it is crucial for what? Network monitoring and performance, and detecting if there is any potential security breaches. So we can say this is a AAA framework that is used where? In the network security part, where it can be authentication, authorizations, and accounting. Got it? Clear now? So this is a concept, and based on this concept only, we can be able to access a particular devices, or we can set up policies or rules who can be allowed, who cannot be allowed for this. Fine? Clear till here? Hmm? It is not a protocol. It is a framework, concept it is. Okay. Now, as we have already discussed IP version 4, so now you tell me the differences between IPv4 and I will write the IPv6. You will first tell me IPv4. All the terms that you write or you know about the IP version 4.
The IP version 4 is a 32-bit
Okay.
IP address.
First thing, it is of
It is
32 bits.
It is a
It has 4 octets. And each octet
each octet have a 8 bit.
is of
8
8 bits. Next.
in a format.
Or we go, okay. So it is separated using dot. It has a range from 0 to 255.
The IP version 4 support VLSM.
Yeah, it supports FLSM, VLSM, and it has different classes. Correct? It has been classified as public and private. Any other feature?
The broadcast.
Okay, it supports broadcasting as well. Then, correct? Then what about IPv6?
Version 6 is a 128 bits of IP address.
IPv6.
So there is 200 that is a ARP2 or basic MAC address. IP version 4.
It uses
ARP4.
ARP.
Yeah.
to
Map,
identify the MAC address of the device with the known IP address. Now, what about IPv6? It is of
128 bits.
128 bits.
8 hexadecimal.
Next.
8
It has
hexadecimal.
8 hexstats.
Separated by colon.
Okay. And what about each hexstat is of how many bits?
16 bits.
16.
16.
Yeah.
Each of 16 bits. And it is
Classless.
separated
Colon.
by using colon. Next is what?
Range 0 to 8.
It has a range. It has range from
0 to 0 to
0 to 255.
no, sir. There is a very
FFF 0 to FFF.
Means it is in hexadecimal form. Right? Then
the IPv6 does not support VLSM.
it is not. It does not have
Suppose
class.
NDP, neighbor discovery.
We'll come to that. Yes, no class. There is no A, B, C, and D like this. No class.
Classless.
Okay, so we can say it is like a classless. Next is what? It does not support broadcasting.
Unicast, multicast, and anycast.
No ARP, no NAT.
No ARP. No NAT is required in this. So what it uses?
NDP.
NDP. It uses NDP. What is NDP? It is Neighbor Discovery Protocol.
Protocol.
Correct, no? Write down all this. What?
I have too many things added.
Tell.
No, just I. आपने बहुत सारा edit किया है इसमें.
Now, what was the requirement for having this IP version 6? So first we had the IP version 4.
Yeah.
Now, at the first, it was supporting only classful network. Later on, we started with the classless network to overcome with the limitation of the IP version 4. Or we can say in the year 1990, we came with the classless. Then this IP version 4 started supporting what? Classless also. Then it was not enough to handle the number of users. That's why, again, we had the requirement for the IP version 6. And one more thing you can say that this IP version 4 is not much secure. IPv6 is secure because what happens in the IP version 4 when we ping, we have checked also that for the first time it generates ARP request, and when we ping, what happens? Some of the packet is being lost. In this, the packet will not be lost. Okay. So again, one certain more features we have in the IP version 6, like we can have here, or it is based on one feature. Let me write that feature. It uses a stateless auto configuration feature. A stateless auto configuration. We'll discuss everything. What is this stateless auto configuration? Okay. So see, it is explaining you with the timeline that in the year 1980, we had this IP version 4. Then the concerns for the IP version 4 address exhaustion was there around in the 1990. That's why we came with the classless network. And then the requirement for this NAT and CIDR came. Then around in the year 2000, the development work for the IP version 6 was started. Okay. And then around in the 2013, we had this IP version 6. And now we are starting using also. So if you will find here that we will be having, when you will check the IP version 6, it has one link local address. See here we have link local address. It is there, no? It means what is happening that the devices is going to have an IP version 4, a default gateway. It is able to reach the internet, but the devices will also have a link local address. See, generally what happens now, at present also your end devices will be having the private IP version 4 only. Okay. To reach the internet, it is going to use what? Public IPv6. Generally, the devices will not have a private IPv6 addresses. Okay. Same, it has been also classified like a public and private. And this is link local is also one of the classification of the IPv6. Fine. So it is going to have certain, like this is the headers of the IPv6 and the,
So it is important to remember that.
no, it is of 40 bytes. This is the size of IPv6 address where it determines the versions, what version you are using, classes, flow labels, payload lengths, next headers, hope limit, source address, destination address. No need to remember all these things. Just you have to know that this is the size of the headers, 40 bytes. Okay. But you can verify also what are the meanings. We'll show you later on about this. First, we'll see what is the IP version 6 and how it looks like. So it says here that IPv6 uses a convenient hexadecimal format addresses. To make it more readable, IPv6 addresses uses a format with the 8 sets of 4 hex digits, which each set is of separated by what? Colon. And this is one of the examples. Okay. Now here what will happen? Your number will be converted into what? Binary form. And based on which criteria it is going to have this? 2 power 3, 2 power 2, 2 power 0, 2 power 1, and 2 power 0. This is the use case. If you remember, MAC address we have discussed. And A is what? 10. B is what?
11,
C is what?
12,
13,
14, 15.
and 50. Right? So let us write one thing. So for example, one example is there for the IPv6 is 2001 : 1234 colon 0001 colon ABCD colon then 0012 colon, how many we have written? 1, 2, 3, 4, 5, 6. Then let's say F E 1, 2, and last is okay. So 1, 2, 3, 4, 5, 6, 7, 8. Now you have to write here. Then you have to use this value. That is 2 to the power 3 is 8. Then 2 to the power 2 is what? 4. Then 2 to the power 1 is 2. And 2 to the power 0 is 1. Okay. Now, for example, if you want to write here, this one, 2001. Okay. So in this, what will happen? You will write this 2 into the bit form. How will you write this 2? See, if you want to write this 2, it means here we are not using 8. We are not using this particular 4. We are using this 0. So 2 will be written as what? 0, 0, 1, 0. Again, 0 will mean all zeros. Same, all zeros. How we write this 1? 0, 0, 0, 1. When you will count, you will get what? 16 bits. Okay. Now, here we have written, let's say FE12. Okay. So as you know that A is what? 10. B is what? 11. C is what? 12. D is 13. E is 14. F is 15. Then if you will write F is what? 15. So how will you write F? 15 means 8 plus 4, 12, plus 2, 14, plus 1, 15. It means all 1. Then E is what? 14. 8 plus 4, 12, plus 2, 14. It means triple 1, 0. 1, again same thing, 0, 0, 0, 1. What about 2? 0, 0. So when you will write all this number to the bit form, then you will get like this 128 bits. Total 128 bits. Fine. So don't you think that my IPv6 address is it's too long?
No.
So we can compress it, right? So there is a feature in the IP version 6 that will be used that is called as a shortening of IPv6. Sorting of IPv6. So there are different conditions to reduce the size. I'm not telling you that we will be reducing the total size, but we can at least compress it so that we can no need to write all this long form of IPv6. Okay. First method. Continuous set of 0 will be replaced with colon. How? 2001 colon 0000 colon 1234. How many we have written? 1, 2, 3, 4, 5, 6, 7. 7 and one more we write, let's say ABCD. Okay. Now what it says that continuous set of zeros will be replaced with what? A colon. Now you will tell me, okay, here we have two continuous sets of zeros.
Yeah.
So according to this statement, I have to remove both the zeros and will remove it with what? Colons. Let's do that. 2001 colon colon 1, 2, 3, 4
Dot,
colon colon
then ABCD.
ABCD. Okay, for example. Now what happened that I have not given you this one, but I have given you this one. Shortened version of IPv6. I told you to you have to elongate it. Fine. So what you will do now, you will write 2001 1, 2, 3, 4 1, 2, 3, 4 1, 2, 3, 4 1, 2, 3, 4. How you're writing? See, for example, you know here that total is what? 1, 2, 3, 4, 5, 6, 7, 8. Right? Here, how many you have written? 1, 2, 3. Now you know total is going to be 8. Here I have written 3. It means when I will remove this colon, total number of zeros I will get here is what? 5. But here also I have colon, here also I have colon. It means somewhere I will get it here as a what? Maybe 2 and maybe 3. But you have written like this. 2 and here you have written 3 and this side you have written 2. But which one is the correct one? This one is the correct one. But you have also not written it wrong. No? It is also not wrong. It is also correct. But don't you think we have a confusion to write the same thing into two format?
Yeah.
We have no. So this method is wrong. Which one is wrong? This is wrong. So whenever it says that you have to remove a continuous sets of zeros, in that case you have to remove only one continuous sets of zeros. Either you remove this one and write a colon, or you remove this one and write a colon. But the name only says shortening. It means what? You will write more numbers of continuous sets of zeros. It means we will be compressing here what? This one only. We will prefer this one only.
Yeah.
So what is the correct answer that we have to write here? When you will compress, you will write the 2001, then colon 1, 2, 3, 4, colon, 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 ABC. This is the correct one. Write down the first point. This is regarding this sorting of IPv6. So whenever you have a continuous sets of zeros, in this single continuous sets of zeros will be removed. What is the spelling here? So continuous sets of zero will be replaced with a single colon, or we can write here weak with single colon. This is the first step. Two more we have. Second one, single set of zero, or you can say single set of zero will be replaced with single zero. It means same thing we can write it here. Just changes will be what? We'll remove here. So what answer you will write? 2001 colon. See, here we have a single set of zero, no? Only one. So you will write here 0.
0.
Then
0 colon. If you want to.
FE 1 2
colon
and 1 2 3 4
colon 1 2 3 4. Then 0
double colon
double colon, yeah.
and ABC. It means we can use all these rules, okay, at the same time. Clear, no? So first rule says that whenever you have a continuous sets of zeros, that will be replaced with what? Single colon. Second rule says that whenever you have a single sets of zeros, that will be replaced with what?
Single zero.
Single zero.
Third one.
And the last one, that is the third one. Leading zeros will be removed. Only leading zeros. How? For example, same. In this, we have written 0 0 5 1 5. For example, okay. Here we have to write 1 0 0 0. And here we have 0 1 9. How will we write? It says what? Leading zeros will be removed. So 2001 colon 0
0 dot
1 5.
Yeah. 1 5 dot
1 0 0 only. This is not leading zeros. Okay.
And then double colon and then 195.
So in this, all the three rules we have used. And it means one more thing here, that all the rules is based on what? Zeros only.
Yeah, that's
Number of zeros. So first thing is what? Continuous sets of zeros will be replaced with what? Single colon. Second says that single sets of zeros will be replaced with what? Single zeros. And then leading zeros will be removed. Correct? Clear till here? After this, we have to discuss about the types of the IPv6 that we have to use. Then that headers that we have seen, their just meanings, what all the meanings we have for each fields. Then we will start with the configuration part. In this, we have one concept called as a stateless auto configuration that we have to discuss. Okay. And from which part it is going to generate the IPv6 address, that also we'll discuss. Network part, everything. We will do a static routing using IPv6 and default routing using IPv6. Okay. This all we'll do tomorrow in the next class. So that's all for today. Let's stop the recording.